everyone, welcome to the class of the Biomedical Engineering. I am Professor Vevhare from Electronics Engineering Department. I am teaching you a Bioelectronics Engineering which having a code of BECL 418. Now, this biomedical electronics belongs to the field of electronics engineering with reference to the biomedical fields where electronics engineer can contribute the way of the electronic instrument and their instrumentation types. For that, how a electronic engineer can help to the biomedical fields. Now, if a electronic engineer is here and it performing a role of electronics as well as the instrumentation electronics engineer, these instrumentation are designed in the way of to give the field to the medical instrumentation. Now, the medical devices are in a wide range of the sectors. This electronics engineer can also introduce where biomedically this instrumentation can be performed, how signals can be captured through a biomedical patients. Now, where a number of electronic instrumentation are designed which are may be a very complex in nature or may be a very simple in nature, but the complex nature or the simple nature is not so important. The important is how they are manufactured, how they are designed. These are the types of the electronic instrumentation where the includes the ECG, EMG, then EEG waveforms. Now, these waveforms or these electronic instrumentations can be formed with the help of very simple diagrams. This diagram is also having the part of sensor, where the sensor can also having the actuators. These actuators and the sensors are directly related to each other. Also, the part which is very important to the role of electronic engineer is instrumentation or the electronic interface. Electronic interface is a very important part of the electronics. Also, with the last part is the computational unit. Computational unit is one of the important part which is also bidirectionally coupled to the all devices. Now, this part is very important because until and unless you do not have any part of the that is called as the tissue, that is the tissue portion, if this part is directly connected to the biomedical sensors, how we can calculate the number of signals. Now, the signals are very important. What is a signal? Signal is a very small type of physical value or the electronic instrumentally it requires a variation in the particular signals which are nothing but the time responses. If time responses is varies as per the value of the input, then we scale as a x axis as a input and y is axis as a output. Then we require a linear shape of the transit time, which is importantly said that we having a actual sensor which are nothing but the responsibility to capture its portion of the sensor. Now, this information is directly coming to the sensor. These sensors are having the responsibility of mostly the sensitive part. This sensitive part is nothing but the reproduce the amount of information to the actuators. Now, what is the role of actuators? Actuators are performing the part of the signal which is captured through this tissue and converting with the help of the mostly the A to D or D to A signals. Now, if we are having the knowledge about the electronic engineer, we require to know about the A to D conversion and D to A conversion. If A to D or D to A conversion is free from SNR value, that is signal to noise ratio, we required mostly a 0. And if we do not have the values about the 0, then we have to think about the proper interface between this particular value. For that, we know about the electronic interface, that is the role of the electronic engineer is over here. How we are interfacing this type of sensor? With the help of amplifiers, with the help of push pull amplifier. These amplifiers are nothing but the balance amplifier, where the amount of signals are captured and the noise all removed with the help of some kind of filters. Now these filters also we required. For that we required a signal to noise ratio with the help of LPF, that is low pass filter. We required a very small amount of signal were captured through this tissue, because this voltage are equals to the very small, that is the millivolt. This millivolt or microvolt are very small to carry forward towards the actual electronic interface. Now actual electronic interface are this type of electronic interface where the signals are amplified, or it may be a boosted. Now these boosted signals are required to captured within that computational unit, where a computational unit stands for the computer system. That computer system is mainly basically a primary or secondary interface where the actual records of the data can be stored. Now these records are very important, because if a tissue is giving the signals within a time span, that is we call a physiological information, that is the time response, that is the mainly it's a time response. These time response signals are in a such a way, if your body is performing any kind of test, if your tissue is giving the signals in a particular within a small amount of time sector, which is actually in a microsecond or millisecond, if these signals are carried out and at the same time your ports of electronic sensor must be open. If it is not happen, then your physiological theory is totally fails, and because of that you cannot give any kind of information from the tissue to sensor, sensor to actuators, and actuators to the electronic interface. Now what we can do? We can do when there are the number of signals, if the time responses of the signals can be matched, then we can actually match the amount of information where the tissue can have the its originality, where how much of sensor it is to be kept, that is the time. Again, how much of proper interface we are doing, it is also important. Then this information can be taken in a such a way so that we can have the actual physiological theory, so that the time and the interface can be matched and we having the actual value at the time of where the signals are generated. These signals are very important because they are not reproduce any much of information again and again. This is the role of electronic engineer, to capture actual information, then it is to be actuated. This actuated information, it is captured with the help of electronic instrumentation. This electronic instrumentation, then it is going to the actual part of the computation where the whole unit. Now a computational unit is actually a one system where the electronic gadgets, then different types of data parts, different types of display unit, different types of recording methodology, different types of graph methodology, different types of imaging technology can be generated through the particularly amount of information. Now depending upon all these types, we are having the data of instrumentation where we are having the direct or indirect, then invasive or non-invasive, then we are having the dynamic or static, then we are having the responsibility and non-responsibility. Now for the direct input, where information from the tissue part is taken directly through the help of the leads or needles, in which your body or your tissue are directly penetrated or having the direct contacts of the information through the sensor part. This sensor part also it is called under the sense which use the touch, and sense which does not having any kind of touch. This touch or this without touch, the information, that is the non-touch information, are directly comes through the particular part, where the best example is of the EEG or the ECG waveform, where the information from through the body of the part, that is the three triangular waves, are coming through the one left hand, then right hand, and then one of the leg. This triangular structure of the body can gives me the ECG waveforms. Then we are having the invasive and non-invasive methodology, where invasive method is very critical, that is if you having the direct penetration into a body or into a nerves, into a artery, then we are having the information through the artery, then we are calling this information through the sensor, where the touch is on the upper face of the body, where the tissue portion are there. If it is inside of the tissue, then we calling this total method under the invasive methodology, where the actual information from the body is taken, and then it is also form of the actuator, then we control with the help of electronic instrumentation, then electronic part is also giving information to the computer side. Then in a non-invasive methodology, where the sense of the information are from the upper side, that is we having the blood flow meter, where the blood flow meter are use a technology where the information through the some kind of responses, that is the sense, with reference to the responses we can measure, and with the help of comparative methodology we can engage all this information through this sensor part, and this sensor part is also included with the help of actuators, and these actuators also performing the role of the electronic instrumentation part and then computational unit. When we are having a non-invasive methodology, we required a particular body which is totally responsible of giving a very sensitive part of the signals, which is because of the non-touch methodology is there, and because we are not penetrating any kind of needles over there. So the response of the body is so important, because the response from the tissue or inside of tissue are very less, which is captured through this sensor, which may be a nano volt also. These nanovolts are required to amplified with the help of electronic instrumentation part. Now this electronic instrumentation part having the one part of the theory, that is how we having the accuracy. Accuracy is a part where a captured value, that is the true value, which is minus a average value divided by your true value, if it is divided, then we having the accuracy of the your system. Again a one term is very important, a sensitivity. What is the sensitivity? Is a part where a one part of the input is giving and it giving me the output. That is why if there is no inputs are coming, how we are generating the sensitivity part, and that sensitivity part is also responsible to generate a next kind of level of signals. In electronic instrumentation, one theory is directly generating a signals where a direct amount of information can be transformed, and secondly it also having the indirect signals are generated. How indirect signals are generated? When if a tissue is performing a very small amount of voltages, and if this information are just compared through the your sensors. Now these sensors are also having of two types. There the active sensors and the passive sensors are there. These active sensors and passive sensors are mostly responsible of the how the tissue is performing. If tissue is not giving so much of amount of information, where the electrical signals are very short in time duration, also the voltage are very small, then these tissues voltages are just compared through the your sensors. These sensors are generally generated the amount of information through their logic, and one reference voltages can be added. These reference voltages are just pass out through the actuators. Now these actuators are performing the role of this instrumentation, where the amount of information again is to be calculated. These are the basic need of the your electronic instrumentation systems, where the basic block diagram is requires a sensing unit along with the actuators, then a instrumentation electronic systems, and then computational units. With the help of all these instrumentation, we can generate a ECG, EMG, then EEG, then man to man interface, where a computer system and the electronic instrumentation system can generate a one biomedical systems, where a biomedical signals are generated, the type of biomedical signals, where a logic of the biomedical signals are totally responsible on the touch and non-touch body surfaces. This, according to this type of information, we are having the types of sensor, where the touch sensor and non-touch sensors are also generated with the help of invasive and non-invasive methodology. These information are very importantly used, where the information from the body side are generally captured to analyze the logical level, where the electronic instrumentation can take a role of how the instrumentation can perform or detect a devices, where a devices can gives me the answer the body if it is effective from this kind of diseases, or this kind of diseases are totally available on that surfaces. Now, this is a part of the first unit that we having the lectures on the how the electronic instrumentation are introduced. Thank you. Shall we having the good lectures.